saw this on the highway, you would call 911. This truck just broke in half at 30 tons, and nobody even flinched. That massive articulated dump truck is navigating a steep, muddy slope at a construction site. It hits a turn, and the entire front section pivots away from the rear at what looks like a catastrophic angle. The cab is pointing one direction, the dump body is pointing another. The gap between them opens wide enough to see daylight through, but that bend is not a failure. It is the entire point. Every major construction site on Earth uses a machine that was designed to snap in the middle, and the reason it works is the same reason your spine works better than a steel rod. Here is what most people never think about. A normal truck, the kind you see on every highway, would be destroyed within hours on a real construction site. And it has nothing to do with power. It has nothing to do with tire size or engine displacement or how many gears the transmission has. The problem is geometry, and it took decades of engineering failures before anyone figured out the solution. Let me show you one. Picture a standard dump truck, the kind with a rigid steel frame running from bumper to bumper. Two steel rails bolted and welded into a single, flexible backbone. Now put that truck on a construction site. Not a paved road, not a graded surface, a construction site with 30-degree slopes, mud that swallows tires up to the axle, rocks the size of watermelons, and terrain that changes elevation every 10 feet in random directions. Here is what happens. The left front tire hits a boulder. The frame cannot flex because it was built to be rigid. So that impact travels through the entire chassis. The cab shakes violently. The steering wheel jerks. The load in the dump bed shifts, and then the rear tires on the opposite side lift off the ground. The frame is acting like a lever when the boulder is pulled. You have lost traction on half your wheels. The truck is now fighting itself. The engine is working harder because wheels are spinning with no grip. The transmission is struggling because some axles are overloaded while others are underloaded, and the frame itself is absorbing stress it was never designed for. Hairline cracks start forming in the steel, welds begin to separate, bolts experience shear forces that push them past their rated limits. After a few weeks of this, the frame fails. Not dramatically, not spectacularly, just slowly and expensively. Structural fatigue accumulates. The truck becomes unsafe long before it looks broken. Rigid frame trucks on aggressive construction sites can develop critical structural issues in months, not years. Some operations have retired trucks after a single season because the frame damage was irreparable. But it gets worse. On a slope with loose material, a rigid truck cannot keep all its wheels planted. When the terrain undulates with bumps and dips and ridges, the frame acts like a seesaw. Two wheels might be fully loaded while two others hang in the air. You cannot climb a 30-degree grade in wet clay with half your tires doing nothing. You will either get stuck and require a $50,000 recovery operation, or you will slide backward down the slope with 40 tons of material pushing you. Neither option is good. Neither option is safe for the operator or anyone else on that site. This is why articulated dump trucks exist. They were engineered specifically to solve a problem that rigid trucks cannot survive. The key is the articulation joint. It sits between the front and rear sections of the truck, and it does something that looks terrifying but works perfectly. It allows the two halves of the truck to move independently, almost like two separate vehicles connected by a flexible coupling. Think of it this way. If you try to push a wooden stick across uneven ground, it tilts and tips. The stick resists the terrain. But if you push a chain across that same ground, each link conforms to the surface beneath it. The chain follows the terrain. The articulation joint turns a 50-ton dump truck into something closer to that chain. Now, the joint itself has 2 degrees of freedom. First, there is the oscillation bearing. This allows the rear section to roll up to 15 degrees in either direction independent of the front. So when the left rear tires drop into a depression, the right rear tires stay planted on higher ground. Both sides maintain contact with the earth. Both sides maintain traction. Neither side lifts off the ground. Then there is the steering pivot. Unlike a normal truck, where the front wheels turn left and right on steering knuckles, an articulated dump truck bends in the middle. Hydraulic steering cylinders push the entire front section to one side. The rear follows through exactly the same path the front took. This gives you a tighter turning radius than any rigid truck could achieve at the same size. A Caterpillar 745 can complete a full turn in 54 feet. Try doing that with a highway dump truck of similar length, and you will destroy the site, the truck, or both. The front and rear are essentially two independent machines connected by a joint that lets them react to terrain separately. The front cab can tip forward over a crest while the rear stays level behind it. The rear can twist to keep 6 wheels grounded while the front navigates around a washout. Neither section transfers its stress to the other. Neither section drags the other into an unstable position. This is why you see these trucks bending at angles that look completely broken. They are not broken. They are doing exactly what 50 years of engineering refinement designed them to do, but bending in half creates a new problem that nobody talks about. If the truck can twist and pivot and oscillate, how do you keep all 6 wheels on the ground and driving forward with actual power? Because traction means nothing if half your wheels are spinning freely while the other half do all the work. The answer is a drivetrain system built specifically for articulated haulers. Every serious ADT runs a 6x6 configuration with permanent all-wheel drive. All 6 wheels receive power all the time. Not part-time, not when sensors detect slip, all the time. But even that is not enough for the conditions these trucks face. Articulated dump trucks use interaxle differential locks. When you flip a switch in the cab, the differentials between axles lock together mechanically. Now all 6 wheels must turn at exactly the same speed. If one wheel starts to slip in the mud, the others compensate with their traction. In the locked differentials force power to the wheels with grip. The truck claws its way through material that would bury a rigid frame hauler up to its doors. The rear bogie system deserves special attention because it is engineering elegance in action. Those 2 rear axles are not bolted rigidly to the frame. They oscillate on a central pivot point between them. When the left rear tires hit a bump, the right rear tires can simultaneously drop to follow a dip. Each axle reacts independently to the terrain beneath it while staying fully connected to the drivetrain. Ground contact never breaks. Power delivery never stops. The numbers prove how well this system works under real conditions. A Volvo A60H carries 61 US tons up 30-degree grades in wet clay without losing traction. The Caterpillar 745 delivers 41 tons at speeds up to 34 miles per hour across broken terrain. The Komatsu HM460-6, which launched in 2026, produces 518 horsepower and includes an integrated rollover prevention system that monitors the articulation angle 100 times per second. These are not theoretical capabilities pulled from marketing materials. This is what happens on construction sites and mining operations every single day. Now let us talk about the dump cycle, because loading the truck is only half the job. You also have to unload it. And unloading 50 tons of rock on a hillside is where things get genuinely dangerous. When an articulated dump truck dumps its load, hydraulic rams raise the body to angles approaching 70 degrees. The rear of the truck tilts almost vertical, with tens of thousands of pounds shifting position. Raise time on a modern ADT is around 11 seconds from flat to full dump angle. Lower time is approximately 6 seconds. During those 17 seconds, the physics of the situation change completely. On flat ground, this works fine. The center of gravity rises and then the load slides out. Simple. But articulated dump trucks rarely work on flat ground. They dump on slopes. They dump on uneven surfaces that shifted since they arrived. They dump in conditions where a 70-degree tilt creates serious tipping risk that could roll $1 million machine and kill its operator. This is where modern engineering gets genuinely impressive. Caterpillar uses a system called dynamic roll protection. Sensors mounted throughout the machine monitor the truck's lateral angle, the terrain slope beneath each axle, and the articulation position all simultaneously. So, if the system calculates that raising the body would cause a rollover at the current position, it limits how high the dump body can tilt. The operator might command a 70-degree dump, but if that angle exceeds the stability threshold on the current slope, the system stops at 55 or 60 degrees and holds. Volvo has stability assist using similar sensor arrays. Komatsu has automatic body height limiters tied directly to their rollover prevention package. Bell Equipment monitors lateral G-forces. Every major manufacturer has recognized that the dump cycle is statistically the most dangerous moment in an ADT's entire operational life. Here is something most people do not realize even after watching these trucks work. The articulation joint actually helps with dump stability rather than hurting it. When the rear body tilts up to dump its load, the front section stays planted firmly on the terrain. That front cab with its engine and transmission acts like an anchor point. The weight concentrated on the front axle counterbalances the rising center of gravity in the rear. And if the terrain starts to shift or the load slides unevenly, the articulation joint lets the front and rear react independently instead of tipping together as one rigid unit. The machine that looks like it is broken is actually more stable during the most dangerous operation than a rigid truck would be. Now let us talk about what all this engineering costs, because these are not cheap machines. A single Caterpillar 730 starts at around $425,000 and can exceed $500,000 with premium configurations including advanced telematics, reinforced dump bodies, and cold weather packages. The Volvo A60H, their largest articulated hauler, exceeds $675,000 fully equipped. Bell Equipment, John Deere, Komatsu, and Doosan all compete in this market with machines ranging from $350,000 for smaller units to over $700,000 for the heavy haulers. These are not one-off purchases. Construction companies and mining operations run fleets. 10 trucks is a small operation. 20 trucks is medium. Some large quarry operations run 50 articulated haulers simultaneously across multiple work faces. That represents $25 million to $35 million in machines alone before you add maintenance equipment, spare parts inventory, and operator training programs. Fuel consumption on a loaded ADT runs between 8 and 15 gallons per hour depending on terrain difficulty and load weight. At current diesel prices, a single truck can burn $500 to $750 worth of fuel per shift. A large quarry operation might consume $50,000 worth of diesel every week just keeping their articulated hauler fleet running and loaded. These machines consume fuel at rates that would bankrupt a highway trucking company within months, but they haul 200 to 400 loads per day per truck. A highway dump truck might manage 50 loads in the same time frame because it has to stick to roads and established routes. It cannot cut across the site. It cannot climb the slopes where the material is. It cannot go directly from the excavator to the crusher. The world's biggest infrastructure projects depend entirely on articulated haulers. Highway systems moving through mountain passes. Dam construction in river valleys. Airport expansions built on reclaimed land. Open pit mining operations extracting billions of dollars in minerals. These projects move millions of cubic yards of material over years of continuous operation. Without articulated dump trucks, you would need 10 times as many rigid haulers working 10 times as hard on terrain that would destroy them in months rather than decades. Here is what makes this engineering even more interesting. The articulation principle shows up everywhere once you know what to look for. Semi-trucks use a fifth-wheel coupling that allows the trailer to pivot behind the tractor. That is articulation. Without that pivot point, an 18-wheeler could not navigate a highway exit ramp or back into a loading dock. Trains use bogie systems under each car. Those wheeled bogies pivot and rotate independently so the cars can follow curved track without derailing. That is articulation applied to rail transport. Also, the human spine is made of 33 vertebrae stacked in a column with flexible discs between each one. Each vertebra is an articulated segment. Your spine can twist, bend forward, bend backward, and flex laterally because it is not one rigid bone. It is 33 bones working together through articulated connections with the discs acting as oscillation bearings. An articulated dump truck uses exactly the same principle that lets you touch your toes. City buses have articulated sections in urban transit systems around the world. Those bendy buses with the accordion joint in the middle let a 60-foot vehicle navigate corners and roundabouts. That would be completely impossible with a rigid frame of the same length. Even spacecraft docking mechanisms use articulated joints. When a capsule connects to a space station, the docking adapter flexes and pivots to align two objects moving at 17,000 miles per hour in slightly different orbits. Articulation in zero gravity. This engineering principle, allowing two connected sections to move independently while staying joined, solves problems everywhere from your backbone to outer space. And articulated dump trucks might be the most extreme terrestrial application of it. A 55-ton machine bending in the middle while climbing a wet slope at 20 miles per hour with 6 wheels clawing for traction. No other vehicle in the world does exactly that. Every time you drive on a new road, you are driving on material that an articulated dump truck hauled. Every building foundation sits on earth that an articulated dump truck moved. Every dam, every airport runway, well, every mine that produces the copper and lithium and iron in your phone and your car. Articulated haulers built the infrastructure holding modern civilization together. The truck that looks broken is the one that never breaks. If you want to see how these machines load that 50 tons of material in the first place, that video is on screen now.